This is my latest piece of junk. 18 volt Erbauer brushless. Apparently it doesn't work. It looks in very good condition. I mean, it has been used because you can see the chuck's got, well, I think that's paint on it. So the chuck's got paint on it. There's a black mark there. There's some scratches there which are odd looking scratches. There's some black goo there. But other than that, it looks like new. Apparently it doesn't work, as I just said. But of course it would need a battery to work. I haven't got a battery. Now I thought I was going to have to work out a way of powering it to prove it doesn't work. Battery, crocodile clips and wires onto here. Hopefully plus and minus agree with plus and minus on here. No way to know without taking it apart. Not even sure if I'll know when I'll take it apart. But if I go like this, you can see, hopefully, but every now and again something happens. But more interestingly is if I disconnect this from the battery for a bit, put it back. Now let's see what happens now. Oh, it's exactly the same. Last time I disconnected it, let's try again, disconnect, add it back. Oh no, it's not doing it. But it actually spun the last time I tried this. I was fiddling around with this and I took it off and I went like that. Oh, there you go, look. And then stopped. So it sort of can work, but obviously not. Well, I've not had much luck moving or removing chucks lately, but let's see how we get on with this one. Crikey. Could this be a non-left hand thread one? That's they're usually left hand thread, aren't they? Well, that's unusual because this Makita's pretty good. I'm using a T-handled PH3 bit and I've managed to get that undone, and it is a left hand thread as usual. But I'm a little bit worried because if it's that hard to get this bolt out, what chance have I got of getting the chuck off? And I've not had a lot of luck lately with getting chucks off, so I'm not really looking forward to that. Oh, it hasn't even got any sponge on it to lock it on. Wow. Right, now we need to encourage this to come off. I'm not looking forward to that bit. Right, we're going to use the old clout the key with a hammer trick, so cover your ears. No, that did nothing. No, that did nothing as well. As you can see, not having a lot of luck. No. No, I'm really not having a lot of luck with this trick lately. So perhaps this is yet another chuck that we can't get undone. No, it's not doing anything. Well, as we can't get the chuck off, let's see if we can get any other part of it apart. Like, even that's tight. These are T10s. Surprised they're so tight. Right, that should be them all. It's got quite a lot, hasn't it? 1, 2, 3, 4, 5, 6, 7, 8, 9, and that one's playing hard to get. Right, so that's those, and then there's one sort of down there. Right, so that's those out. So okay, why are you moving this end and not this end? Ah, sticker. Being crafty and putting a sticker on it. Can we get half a sticker off? Oh, we can. Crikey, you wouldn't think the sticker was that tight, would it? Look, that comes off now. Right. Wow. The world's weediest motor. My God, look at that thing. Oh, that's embarrassing, isn't it? Oh, talk about weedy. Right. Well, we've got a lot of electronics packed into small space. And of course this bit is completely potted. So if this bit is the problem, we're stuck. Let's see what we can do. Does this lift out? You can see we're going to have fun, aren't we, trying to get all this lot back in. My God, look how tight it's packed. So that lifts out. Let's pop that LED. Crikey, even the LED's jammed in. That lifts up out of there, that lifts out of there, and the wires are so pushed in they don't want to move. And I think it's partly because this, yeah, the circuit board's jammed in as well. Right, so we've got blue, yellow and sort of pinky brown. Oh, they must be our three phases. They go all the way up there. So it's worth noting they go through that gap there, up here, up here, up here, miss there, up there, to there. Right, so that's that. And then this lot, we've got no reason to think there's any problem with any of this. So can we lift that out? Yep, that can come out. So we worry about the drive bit later. Don't know if we'll end up cleaning these. It doesn't look as if it ever got a chance to get dirty. So that's those bits. So this is the whole thing that's not doing as it's told. Oh, of course, and without its supports, it's just resting. Yeah, you can see it's just resting on the magnet, so it it doesn't want to turn. Yeah, I can't blame it for that. Yeah, the little bearing there. Bearing's fine. Bearing fine. Yeah, so it looks like what we've got is some sort of electronics problem, doesn't it? Switch. Change direction. Oh, well, maybe we were right, because that looks like it is plus, that looks like it is minus, if the colours are anything to go by. So what on earth's that green? Because obviously I wasn't powering up the green wire, because I don't know what the green wire does. Well, that's odd. That just looks like two capacitors on a board. Perhaps they just couldn't fit them on here and stuck them up there. Right, I don't want this bit accidentally trying to take off while I'm testing, so I think what I'll do, I don't know if it matters, I'll try and pull that out. I mean, it looks perfect. I just can't get over how small it is. Maybe being that small is what it needs to be, I don't know. And why has that got a black line on it? Well, worry about that. Now, we think that one's minus, and we think that one's plus, and then when we close this, we've got a little light there which we're expecting to come on, and it does. Oh, and it stays, oh right, so presumably it stays on for a fixed set of time. Oh, it didn't that time, did it? Oh, now it's just flashing. So if we take that off, maybe it's got something to do with the capacitors. Surely not. Put that back on there. Press that. And it's on, then it goes off. And now it just flashes. Going in it flashes, coming out it flashes. Flash, 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 flash. But if we disconnect that for a bit, will it go back to doing that again? Yeah. So it behaves normal for a second, and now it won't anymore. That's odd, isn't it? Now, where do we get to? We can't measure any voltages there because we can't get to anything. We can't get to anything down here, so we can't measure it. We can't get to anything anywhere, can we? So how do we know if we're getting any power to any of these bits? We need a way to puncture into there, I think, but I'm not sure that's going to tell us anything, because I'm wondering if this... I'm not quite sure how these things work, but does it send AC signal up here, or is this 3 different DC lines? I don't know how these work. So I don't know what I should be trying to measure. Let's try and see what's happening up here at the switch, because I think we can reach the switch. That's plus and that's minus. Oh, and if we turned it on, I don't know if you can see that. Let me come over a little bit. I hope you can see that. What's that got read there? Nothing. So that's plus and minus there. Apparently, if we press the switch, oh, do you hear that? Funny noise. Oh, and it's gone back to doing its usual thing. But we're not getting any. Oh, let's try disconnecting that. Reconnect that. Back on there. Oh, no funny squeaky noises this time. But now, and we're not really getting anything of any real sense to measure there, are we? So is that a diode across there? Let's turn it over that side a minute and have a look. That's definitely a diode there, isn't it, from there to there? So we should... Hold on, let's just disconnect the power a minute, in case that's the problem. Put this on diode check. Right, that should be diode check. So between here and here, we get 0.5, and if we go the other way we should get nothing, I think, and we do. The diode seems to be okay. Right, we've got two capacitors here, not showing any sign of bulging or anything, so they seem to be happy. So we've got up in the megohms, and then we push the switch in and it goes right low, so that is presumably on. I'm not sure if there's any kind of variableness to it because the spring's too strong to go gently, but that seems to be simply on and off. But there could be a variable output. This could just be on off, and these could be some sort of variable. So I suppose it's possible there's a slight variableness built into it. But we're sort of stuck then, aren't we? Because it looks like the fault is something to do possibly with the electronics. And the electronics are seriously buried by those things. Well, just so that you know what I'm trying to do, I'm going to have a go at digging away some of this, whatever it is, silicon perhaps, I don't know what it is, but I'm going to have a go at digging away some of this stuff because clearly the electronics are all in here. I mean, the switch could be faulty, I suppose. The capacitors seem okay. I'm going to have a look and see what's going on inside here. In an ideal world we'd just swap this and then see if it came back to life, but of course I can't do that because I haven't got another one. I'll bring you back once I've dug some of this away. Right, this did not go well. It's taken me about 3 hours, so it's a good job I wasn't recording and you were watching. In the end, to get this circuit board out of this sort of protective tray, and I don't know if it actually works as a heatsink, but in the end the only way to get it out was to cut a slot there all the way across and then use this spudger and put it in through the back like that to try to cut away the silicon compound that was underneath. And you can pretty much guess what will have happened. It's damaged some of the components underneath here, and I don't actually know which. In other words, there's a whole row of stuff there and I don't know if they were ripped off or if they were never there. It seems unlikely they were ripped off because I didn't hit this, but there's a diode there. I think that's a diode. You probably can't see it, but it's there, and that is definitely damaged. That's broken. So I'm sort of stuck at the moment. It seems to have provision for pairs of MOSFETs, so it looks like it's got 1, 2, 3, and it could have another 1, 2, 3, and then it's got 1, 2, 3, and it could have another 1, 2, 3. So I'm not quite sure how that's supposed to work out, but it looks like, I mean, I could be completely wrong, but given that that's one output there, that's one output, and that's one output, it seems to suggest that these two are for that output, and these two are for that output, and then these two are for that output. So perhaps the ones that are not present would give it the ability for more power, and obviously they felt it didn't need more power. I'm assuming this is the brain box that actually makes the whole thing work. But as I say, there's 4 diodes there, but this end one is definitely damaged. This is some of the mess that came out of that. Right, you might not be able to see this, but I've brought you in as far as I can to get you as close as I can. These appear to be diodes. There's one there, and one there. And this end one, I don't know if you can tell, but if I poke it, I can lift it up. So this M1 is broken. Now I don't know if I broke that trying to get it off or if it was already broken. My guess is I broke it. I'm going to try to desolder that diode. And I'm going to try using the soldering iron, but as you can imagine it's not going to be easy to get at. And I wonder if I need to add some different solder. Oh no, that's melted okay. Oh, well, there's part of it just broken away, so that obviously... Oh, sorry, I've just bashed you. That's come off, so I don't know if that's part of the pad or part of the part. No, I think that's the pad. So we should, with a bit of luck, be able to heat this side up, get the whole thing to come off. And you can see it's a bit coming off in pieces. Right, so that's one solder pad there. I don't think there's anything that shouldn't be there. That's the other solder pad there. And it looks like you've got 1, 2, 3, that one I've just taken out, and now we've got room for another one there, and it looks like there might have been room for another one there. Now, see, it's impossible to know. I mean, did I knock them off? And then there's something that was here, and here, and here, and here, and here, but I don't know what. That there says C27, C14, so I suppose it's possible there were capacitors here, or they were never fitted in the first place. I simply don't know, because there's a little bit of damage to the board there. So I'm sort of stuck, but what I need to do is find a diode similar to these. It looks like it's saying that that's positive, and that's positive, and that's positive, so presumably this one is positive, but this one hasn't got anything next to it. Typical, isn't it? The one that we need to replace. Right, with luck you can just see I've soldered just an ordinary diode here. There it is, from there to there, because I haven't got any surface mount ones that size. The only ones I've got are bigger. Funnily enough, the only diodes I've got that are surface mount are easy as big as that one, if not slightly bigger, so they won't go on the two pads. So I've just put that leg there and that leg there, and I'll try and see what happens. You might struggle to see these, but I've been digging through the remains of this stuff, the goo, and I found a capacitor, and I actually found two, but one of them just disappeared. I tried to measure the capacitance and it flew off, and this looks like a complete diode and this looks like a broken diode, so it looks like at least two more diodes are missing and at least two capacitors. I've sort of reached a dead end. I've put or soldered that diode back there, so I've got 1, 2, 3 untouched diodes. I've put that one back, which does appear to be working, but I'm still missing a diode there and a diode there. I'm missing what I believe is a capacitor there that matches this one, and a capacitor there. So that's 1, 2, 3, 4 components missing. Then I think this is a row of 1, 2, 3, 4, 5 capacitors to build up a bigger capacitance, and I haven't got those either, and I can't be sure, but I think they probably were there originally and I've knocked them off. There was something there, I think, and I'm not sure what. It could have been a resistor, it could have been a capacitor, so that's another thing that's missing. And somewhere on here, I can't actually see at the moment, but somewhere on here I did notice a couple of other things that could be missing. I think there were a couple of other diodes that might be missing. So there's somewhere around about 8 or maybe even 10 components that could be missing off of here, but I'm not sure. So I don't see any way I'm ever going to be able to repair this, because I don't actually know exactly what bits to put back. So I'm completely stuffed, and I can't buy one of these. I've given these a good wash, and you can probably see, I mean, it's just come up like new. I mean, it really is. It's like new. I mean, even the insides come up. Lovely. What I'm going to try to do is to assemble just this motor part back in here and the wires from the motor will stick out where the switch goes. And then I'm going to try and see if I can find a generic board like this, but obviously it won't be like this because I can't find one like that, but see if I can find a generic board to actually test whether it's ever possible to get the motor to work. So the first thing I need to do is I'm going to unsolder here so I can get this part completely separate from the rest. I can't quite believe this, but it's taken me nearly 10 minutes to unsolder these 3 wires. Just could not get enough heat into it, so I got there eventually. Right, now this part I have cleaned up a little bit, so it's looking a lot smarter than it was before. So again, that needs to go onto here, and it sits there. There's the speed change thing. I don't really need the speed change thing at the moment, but I suppose it doesn't matter if we include it. It just sat in there, and then of course this sits in here and helps support the bearing, so we need that in the right place, and then that sits down in there, and then that of course is now not sitting in the right place, but we might be able to, there we go. Right, with luck that's all back on. That seems to be fitting okay. We just need to find the screws. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, I've put them all in loosely with my fingers, so we should be able to do them up now. Obviously not worried too much about things at the moment, because we can't do anything till we can find a way of powering up the motor wires. But at least now I can leave this lying around, and at some point, if I manage to get hold of a controller, we can have a further experiment. This is a bit of a mess, but you're seeing it exactly as I've just been experimenting with it. 18-volt battery, negative supply straight to this board, positive supply through the switch back to that board. So the switch is not doing anything apart from on or off. That's it. The rest of these wires not connected. Over on this side I've got a switch which allows me to copy this bit of the switch here, which is left and right rotation. So that will give me left and right rotation if the diagram that I got from China is correct. And this is a variable resistor which should be built into there, so that as you press the trigger you get more oomph. This is a circuit board from China that's supposedly a universal board. Now you can see my problem is going to be, that's the size of the old one, and it was that thick, and this one is not only bigger but it's twice as thick, so I don't see much hope for getting this in there. In fact, it might be 3 times as thick because of these capacitors, so I don't see much hope for getting this into there. But what I want to know is, can it work? So we're all connected up. When this is in the middle position, we're not left or right, but apparently we are. I can't explain that, but I'll move that to one side, so we're either forward or reverse, I'm not sure which. Let's pull the trigger. we go. So we're going one way, and if we turn this at the same time, we can go slower, or we can go faster. I'll leave it on full blast. Now you should be able to see it's going that way, so if we now go to the other side, it should go that way. And it does. So the switch and the variable bit seem to work, so I just need to find a way of getting this part to work in place of that part. And this is giving me lots of grief. I'm sure somebody out there knows what these wires are and what they do, but I'm having terrible trouble working that out, and I'm terrified of getting it wrong on this board, because if I do, I'm pretty sure the board's going to go pop. Right, you can ignore the drill. The drill has to be there because I've got the switch over here. 3 volts, LED. I believe the red wire is the output, and so I'm using the black wire as the input, and this is the switch for direction control, and at the moment the LED is off. If I move it to the middle, it's still off. If I move it to the right, the LED comes on. So the power is going through the black wire, cross through the switch, back through the red wire, turning it on. I'm always considering the red wire as being the output. Now if I take that one out and I put the white wire in instead in its place, now of course I've got nothing. And if I move it to the middle, I've still got nothing, but if I move it to the other direction, I've got the light on. So it would appear that these two, white and black, are the switch contacts for the red output. So I think one of these is plus and one of these is minus, and then this is what gets connected. So if we say black is plus, I don't know which is plus, but let's say black is plus, then when the switch is in one direction, plus will go through and come out of here. But when it's put in the other direction, here will be connected to minus, so minus will go through and out here. Excuse my bad use of electricity terms, but you get the idea. So this can either be plus or minus, or 5 volts and 0 volts. And I think that is what triggers the circuit board to decide which direction the motor's going to go. So when it gets 5 volts it goes in one direction, and when it doesn't get 5 volts, in other words it gets grounded, it goes in the other direction. So I think that's those three, which leaves me, what are these two? Now I'm pretty sure there's something to do with variable resistance, but what? Right, if you look at the meter, I've got resistance and I'm measuring between the yellow wire and the green wire, and it says I've got 70 kiloohms. And if I press the switch in a tiny fraction, I've still got 70. Fraction more, you can see it's dropped to 50. Fraction more, 40, 20, 10, and then effectively I think that's as close to 0 as it goes. So I'm presuming that would be full speed, and then as we come out it would get slower and we would stop at 70. Now my problem is that when I look at the variable resistor that I tried to wire up, it had got 3 wires, but I've only got 2. So I'm a little bit confused, and I don't know if these are in any way connected with those 3 over there. So that's what I need to work out next. Right, I'm not sure you can call this much progress because I still haven't got anywhere with these two, but I've now wired the switch direction straight to the board. So if I press this in now, can see, it's going clockwise if you're the motor. It's going, you know, that way if you're the motor. And then if I turn this to the middle, obviously it doesn't work, and if I turn it the other way, it's now going anti-clockwise to the motor. But of course there's no variableness to this because we still don't know what these are, but I have got this attached, so if I this will adjust the speed quite happily. I just can't work out how these are supposed to adjust the speed. Right, I guess somebody who knows more about electronics than I do will understand my dilemma and at least be able to explain it. But I've got two wires here which appear to be for the variable speed, but when I use the potentiometer for the variable speed, I've got 3 connections. Now, what I'm wondering is, do you actually need that third connection? Because if you don't need that third connection, which is the ground, and you only need an in and an out, then that would be an in and an out. So at the moment we've got that on there, and then we're working, and obviously this is the speed control. So what I'm going to do is I'm going to unsolder the ground. So I'll just disconnect that. I'm going to unsolder the ground from here. And so what I'm wondering then is, will it still work with just those 2 wires? Because if it will, then maybe it will work with just these 2 wires. So if I put that back on there, now, does our variable speed still work? Yes, it does. So although that's got 3 connections on it, and according to the internet that's plus, minus at that end, and then the output in the middle, which is our variable output, it would appear that we only really need that one and that one. Now the problem is which of these is those. Right, I've got this on resistance over here, and if I connect between the green wire and ground, which I assume is ground, got 70, and if I press the button in, I've still got 70. I get some sort of fiddling about on here, but basically it stays at 70. So it's as if that wire doesn't change. But if I put it on this one, and then I go to the earth wire, I've got a very low reading, and then as I go like that, it goes up until it hits 70. Now I was expecting it to start at 70 and go down, but this one, the yellow one, does seem to be variable. But I could be connecting it to the wrong point for all I know. I'm pretty sure you couldn't connect these to earth or the minus, the ground, because there'd be no power involved. So clearly one of these has to go to power to get some power, and one has to be the output. So I'm gambling on the fact that the yellow one is the output. So I'm going to connect the yellow one there, which is the variable pin, and I'm going to join the green one to the live pin and take it from there. And I can do that by just unsoldering at this end and connecting at this end. We can tidy that bit up later. But if I was to take that off, that's our variable input. So if we join those two together, that will give us something variable from the switch in theory. If I could get these two to go together, I'd probably need a bit more solder, but I can't do that without having 3 hands. Right, so I'm just going to solder our variable wire from the switch, the one we think's variable, onto our variable input, and then we need this, which is currently our 2 live, so it's our directional live and our power live, and I'm going to join that one onto it so they're all joined together. Now I'm terrified to do this because this is the problem with when you don't really understand exactly what it is you're doing, because I don't want to damage the board. Right, hopefully they're soldered together. Let's hope nothing goes bang. Connect that onto there. And we've got variable speed. Look at that. That's about as fast as I walk. We finally got it. Got that far at last. Right, I know there's no chance of this fitting in there, especially when it's got this thicker heatsink on it. So I'm going to take this heatsink off and see what we've got underneath there. So it looks like we've just got 4 screws holding this on. Doesn't want to come out. Oh, there it goes. Right, well no, they are proper bolts, so it's been properly done. It's been threaded and everything. I was expecting self-tappers. So that's 4, and then I think there are spacers, which there are. So we've got 4, oops, plastic spacers. And then I think that's one of those sort of cooling pads so the heat can get through onto here. Now obviously the existing one that was in there before, these were surface mount, so they took up a lot less space. I don't think they were anything like the sort of power that this would offer. Now the problem is that that has got to sit in there like that, and I think depth wise it might fit. Thickness wise I have my doubts, but length wise I'm sure it will not fit. I'm pretty sure that we haven't got enough room to go from here to here. Right, there's the original board, so you can see the amount of space and the depth, and then here's our board which I'd like to have as a replacement. Now, it might just about fit. I don't think they will, but we never know. But even if we could get that to just about fit depth wise, you could possibly see if I turn it that way, it's about 2-3 millimeters longer that way. This is not connected to anything, I'm just showing you, so I can pull this all out, and that's the one that got damaged taking it off anyway, so that one is definitely dead, and that's the little box that it fitted in. So we can see that if I get that pretty much bang on there, we're this much too big, but this way we're okay, and depth wise for a little bit we're not too bad, but all the components on the top stick up too far. Now let's see what we can do. You see there, I think we might have a possibility of getting that in, but over here we've got no possibility at all. And the big problem at this side is there's a screw, so we can't come this way because we're going to hit that screw post, because the original one, if you look, is resting just before that screw. Now we could come this way possibly, I don't know, a millimetre maybe, but that wouldn't be enough to get the board in, because if we come right to there, it's very, very close. It really is very close. But I've got a sneaky feeling that what's going to happen is that these are going to hit this. So the only chance I can see is if we go the other way, but it's still going to be touch and go. The problem we've got here is this bit, because this fits. If I cheat a bit, no I can't, it's difficult to, that's got to go round there somewhere, but this fits just down into there. Not quite sure if that's gone. See, so we haven't really got a lot of room to come this way, because we can't move this because the battery won't go on if we move this. So we're sort of stuck, but we just might be able to go that way enough. It's just feasible. But the only way to find out, of course, is to cut this away, which is such a pity, because I can't put it back once I've cut it away. Right, I didn't show you cutting this piece out because I cut it out with a knife and it's taken some considerable time, but I wanted to do the absolute minimum amount of damage, so that was sat down in there, but we have got some space. Now the question is, what can we do with that space? Now, will that fit in there? Right, that's the switch wiring removed, so we've got plenty of room there now, and of course we've got plenty of room here at this end. And our problem is, does this fit? And the simple answer is not really, because it will only go that far before these start hitting the side. And I suspect we've got the same problem at this end, that they're going to hit the side as well. Right, things are starting to get nuts here. I've taken this capacitor off of there because it sticks out and gets in the way, and I've taken that capacitor off there because it sticks out and gets in the way. Right, I've just taken another capacitor off. This is an old heatsink of some sort. I can't get it in there at the moment, but I can at least just test the fit, and it's going to fit. I mean, it's not as nice as the thinned one, but it's not far off being as good as an old aluminium can. Alright, it fits, it's on, and the board is in, and it's sort of got a heatsink, but there is a slight problem. I've got nearly as many bits out here as I have in there. But when you take this off, and it's a tight fit, but that's because it's a tight fit everywhere, not because of my board. But when you take this off, you can see there's the board, it sort of fits, there's the heatsink, it sort of fits, there's the connector, it sort of fits. So we're more or less there, but I've got these two that need to go somewhere, and they're just not going to fit. No matter what I do, there's nowhere to put them, they're just not going to fit. These three are, I think, the equivalent of like this bit, which was separate on the other board. Value's different. This is about 900 and, well, it's what, 470 and 470, so 940, whereas these is 3220s, so it's 660. Now, possibly I can just use that. I really don't know, but what I can try to do is make a little board for those and fit them in up here, because that's where that went before. But of course I've got no way of knowing if all this stuff is actually going to work. I mean, I don't know. But bear in mind that I've got to have room for the switch and the wires, so you can see that if I try to get these three in there, I may be a bit of a problem. So I may have to try to change these, because this obviously does fit, or at least it did fit. If I could change these so that they match those, that might be an answer, but it still leaves me with the problem of what do I do with these. Right, I've finally sort of assembled this. That's the board that I bought. That's a thin sheet of aluminium, and underneath the thin sheet of aluminium, or on top of the thin sheet of aluminium, there is a piece of that sort of weird rubbery stuff that's supposed to conduct heat. So that's sandwiched between there and there. Here is a row of 3 capacitors to replace the ones I took off the board, and then the 2 capacitors that were over here blocking our way are now tucked up like these sort of blobby things here. So they've got some heat shrink over them and they're tucked up over there. So in theory everything is back in. The only thing that's not back in is this, which is the little LED that goes on the front. I still want to do a little bit more tidying, so I need to test, does this actually all fit together before I worry about that. But I'm going to try to get that so that it works on the trigger, so it won't have a delay to stay on or anything like that. It'll just come on when you press the trigger, go off when you release the trigger. So I've just got to try and find out if it fits. I've got it all back together again, but there's a problem. It sort of works. Watch, when I pull the trigger, I've got fantastic fine control. And not bad, but if you watch, if I go, see what happens. But if I pull the trigger and hold it, it will ramp up fine. But I'm pretty sure it should ramp up a lot quicker than that. So if you go like that, you sort of beat it. I don't know if it's something to do with the resistance, because once it gets going it's absolutely fine. So if we're screwing into, let's say, an existing hole, and it's on fast speed at the moment, you can see it's taking time to get going. Let's try it drilling into a non-existing hole, but you can see if I pull the trigger, pretty slow, but it's, you know, it's there. Oh. Well, it seems to be developing the power, it just not straight away. Right, it's a 10mm drill bit, so let's just try drilling. Well, it's not having any trouble with that. Gotta be careful, I'm trying to go right through my bench. Oh, I can go a bit further. So it will drill. Fixed.